Hi everyone, welcome to homework 1.24. Today we are looking at graphing systems of inequalities. So it looks like you all were doing a really good job with this today in class. Let's go ahead and take a look at today's homework. I'm going to do the homework first and then I'll go back to the classwork to go over it. So y is less than or equal to 3 means that we're looking at a boundary where y equals 3. So my dot would be across anywhere that y would equal 3, which is therefore going to form a horizontal line. Now this is less than, so it's going to be a dotted line. And it's less than, so if I plug in the point 0, 0, 0 is less than 3, that is true. And so that tells me that I'm going to shade this underneath the line. Now for the other equation, I'm looking at a y-intercept of 1, so I'm going to start here, and then it says it's a negative slope, so it's going down this way, and it's negative 1 over 1. So down 1 over 1, down 1 over 1, down 1 over 1, and it should be forming a downhill slope. This is greater than or equal to, so this is going to be a solid line going down this way, and then I'm going to shade a side. So let's plug in the point 0, 0 and see if it works. So 0 is less than or equal to 0 plus 1. That is in fact true, so we're going to go ahead and shade underneath this line like this. And so the part that is connected or overlapping is underneath in this area here. And so anything in this area will fulfill both of those inequalities. Let's look at the next one. So the next one says 4x minus 3y is less than 9. So the first step I need to take is to put this into slope-intercept form. I noticed a lot of you all today trying to just do this in your head. Show your work because you need to pay attention to these negative signs. So you're getting negative 3y is less than negative 4x plus 9. Now I need to divide both sides by negative 3. Remember, when I divide by a negative, this sign needs to flip. So that's why I'm saying show your work, because then we're going to rewrite this as y is greater than 4. Negative 4 over 3 is going to be positive 4/3 x. Negative 3. 9 divided by negative 3 is negative 3. Okay? So now I can graph this first equation. We're going to start here at negative 3, and then it's a positive slope, so I'm going up 4 over 3, 1, 2, 3, 4, over 1, 2, 3, and it's greater than, so there is going to be a dotted line connecting these points, and you can extend it up above like this, and now I need to test a point. So let's test 0, 0. If I put 0 is greater than 4/3 times 0 minus 3, that'll be 0 is greater than 0 minus 3. That is true, so we know that we're going to go ahead and shade in this side. Okay, if it didn't work, I would shade the other side, but it does work, so I'm going to shade this side, and now we're going to test the other point. So let me go ahead and show my work over here. X plus 3y is greater than 6. Again, we're isolating the y, so we're going to subtract x from both sides. We'll get 3y is greater than negative x plus 6. Divide both sides by 3. Now in this case, I'm dividing by a positive number, so my sign can stay the same. Y is greater than negative 1/3 x plus 2. This negative x over 3 is, remember that invisible number in front of the x is 1, so we can rewrite that as negative 1/3 x. Okay, so positive 2, that's going to start my y-intercept, and then I have a negative slope, so it should be going down. It's greater than, so I'm going to have a dotted line this time. I'm going down 1 over 3. Down 1 over 3, we should be over here somewhere. I would go up 1 over 3 this way, so that we have more lines to connect, and I'm going to go ahead and dot those lines there. All right, now I'm going to test a point. I'm going to test 0, 0 again. So if we plug in 0 plus 3 times 0 is greater than 6, that is not true, right? This point does not work for the second equation. We can test it here as well. If we say 0 is greater than 0 times 1, negative 1/3 plus 2, 0 is not greater than 2. So this side does not work. So for my second line, I'm actually going to be shading the other side above the line here. okay? And so now the conjoined areas, or the areas in which we have overlapping shading, are going to be in this zone right here. That's where they're overlapping. All right, let's take a look at this next problem. So it says two inequalities are graphed on the same coordinate plane. Which region represents the solution to the system of the two inequalities? So we're looking for the overlapping zone. The overlapping zone would be here in D. So D is our answer. D, because it is shaded for both. All right, number 2 says select all the pairs of x and y that are solutions to the system of inequalities. So for this one, you would need to plug in both of them and see if they work in both. So if we plug in 0, 0, if we plug in 0 is less than or equal to negative 2 times 0 plus 6, 0 is less than 6, less than or equal to 6. So A works for the first equation, the first inequality. Let's try for the second one. So we have 0 minus 0 is less than 6. That also works out. So A works for both of them. A is the solution for both. Now we have to test B. So we plug in negative 15 is less than or equal to 2 times negative 5 plus 6. Negative 15 is less than or equal to negative 10 plus 6. Negative 15 is less than or equal to negative 4. That is true. So it works for the first one. The second equation would be negative 5 minus negative 15 is less than 6. We'll get negative 5 plus 15 is less than 6. And that would be 10 is less than 6. That is not true. So B only works for one equation, not for the other one. Okay? Now, another way that you could do this is you could graph these two inequalities and see what you get and see if these pairs belong in that quadrant. So that's another way that you could do that. If we were to graph that, we need to write this in slope-intercept form. So this would be x minus y is less than 6. Let's move the y to the other side. So let's add y to both sides. Then we get x is less than 6 plus y. We need to subtract 6. And so we're going to get x minus 6 is less than y, or y is greater than x minus 6. So now we have our y-intercept at 6, and it's a positive slope of 1 over 1. So we're going to go up 1 over 1, up 1 over 1, up 1. Let me make sure I'm doing this right. Up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. Right? And so forth and so on. Okay? And so this will be dotted line. And then it's greater than, so if I plug in 0 is greater than 0 minus 6, that is true. So this side is going to be shaded for that line. For our other one, we have a slope or y-intercept of positive 6. So that's the other direction, 1, 2, 3, 4, 5, 6 up here. And we have a slope of negative 2, so going the other way. Negative 2 over 1. So down 2 over 1, 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 and so forth. So it's going to go down this way. And this is a less than or equal to, so it's going to be a solid line. All right, and it's less than or equal to, plug in 0 is less than or equal to 2 times 0 is 0 plus 6. That is true, so we know that the 0 point works. So I'm going to go ahead and on this side, I'm going to shade here. So now anything in this double shaded zone is going to be a solution, right in here. So this is also a way to check. And we can see that 0, 0 is in here, right? Negative 5 comma negative 15 would, assuming we extend this line, be too far down below. Okay, 4 comma negative 2, if we go 1, 2, 3, 4, and down 2. Ooh, from this graph, it's actually a little bit hard to tell, so it might be a good idea to plug those in and try it. Okay, on your graphing calculator, it might be easier to see. Oops, that's not what I meant to do. Let's erase some things here. Okay, So graphing can help you to find those solutions if you have a pretty accurate graph. Let's try this though. Negative 2 is less than or equal to negative 2 times 4 plus 6. So negative 2 is less than or equal to negative 8 plus 6. Negative 2 is less than or equal to negative 2. So that is equal to, it works for that one. For the second one, 4 minus negative 2 is less than 6. This gives us 4 plus 2 is less than 6. 6 is less than 6. So it does equal 6, but it's not less than 2, so that would be, right, it's right on this boundary here, which is why it works for the first one, but not for the second one. Okay? Let's look at the next one. 3, 0. So you're just plugging in these numbers and making sure they work for both equations. So 0 is less than or equal to negative 2 times 3 is negative 6 plus 6. So that is 0, negative 3. If we were to graph that, it would be 1, 2, 3, approximately here. It looks like that's going to work, but let's just double check. And then the second equation, we have 3 minus 0 is less than 6. 3 is less than 6, that is true. So that does in fact work, and we see that on this graph as well. And then 10, 0. So 10, 0 would be like all the way out here. And so that, from the looks of the graph, is not going to work, but we can double check. 0 is less than or equal to negative 20 plus 6. That is true, because 0 is less than negative 14. But if we have 10 minus 0 is less than 6, 10 is not less than 6. So again, that would work for one equation, but not for the other. So that is not a solution. All right. Number 3, Jada has $200 to spend on flowers for a school celebration. She decides that the only flowers she wants to buy are roses and carnations. Roses cost $145 each, and carnations cost $65 each. So we have a budget as one constraint. She buys enough roses so that each of the 75 people can take at least one rose. So 75 is the number. So it says write an inequality to represent the constraint that every person takes home at least one rose. So at least would be greater than or equal to 75. And then we have, let's say, just x plus y, where x is our roses and y is our carnations. And then it says the cost constraint. So 145x plus carnations 0.65. Y is less than or equal to 200 because we have to have a constraint there. That's it. That's all you have to do for that one. You're just writing those inequalities. Number 4. Here are the graphs of the equations 3x plus y equals 9 and 3x minus y equals 9 on the same coordinate plane. Label each graph with the equation it represents. So which of these, the blue graph or the green graph, is which graph? So to do that, let's put them into slope-intercept form. So 3x plus y equals 9. We're going to subtract 3x from both sides. So we'll get y equals negative 3x plus 9. So here we should have a positive y-intercept and a negative slope. So that goes with the blue line. This is a negative slope. It's starting at approximately 9 up here. And so this one would be 3x plus y equals 9. The second equation, just to verify, we will get 3x minus y equals 9. Subtract 3x from both sides. You get negative y equals negative 3x plus 9. But then we have to multiply or divide by a negative 1. So you get y equals 3x minus 9. So that's this minus 9 here as the y-intercept and a positive slope. So this is the second equation of 3x minus y equals 9. All right, so it says label each graph with the equation it represents. We did that. Identify the region that represents the solution set to 3x plus y is less than 9. Is the boundary line part of the solution? So we have to shade in the region. So for this line right here, if it is, if it is less than 9, then let's try to plug in a number and see if it works. So we plug in 0. 0 plus 0 is less than 9, yes. So that means that for this first line, we would shade on this side of the graph. Okay? And it should be a dotted line. So I'm going to erase my line. Oh, whoa. I'm going to go ahead and change this to be a dotted line. And it does not include answers because it's less than. So no, the boundary is dotted and therefore does not include the answers, or those as solutions. C says identify the region that represents the solution set to 3x minus y is less than 9 is the boundary line part of the solution. So if we want to make this other one less than 9, let's test our point of 0, 0. And if we plug in 0, 0 minus 0 is less than 9. That is in fact true. So again, for our other line as well, we're going to be looking at coloring on this side of the line, because that does work. 0 minus 0 is less than 9, so that side works too. So now we have places where our graph overlaps, right in here. All of that area is overlapping. So it says, and then in this case it's less than 9 too, so no, because it is less than 9. So again, let's go ahead and go back and we'll make this also a dotted line. It says identify a point that is a solution to both of them. So all you have to do is select any point, right? 0, 0 is the most obvious one that is a solution to both. If I plug in 0 here, I get 0 is less than 9. If I plug in 0 here, I get 0 is less than 9. Boom, 0, 0 is an obvious one. You could also say negative 2, 0, negative 2, negative 2, negative 4, negative 4, right? Negative 4, negative 2, whatever you want. Anything that's in this pink zone up here. All right, so this part right here is not mandatory. It's just in case you needed to practice that. Make sure that you remember that this is the less than sign, this is the greater than sign. So you can practice that on your calculator at home if you like, just to get some good practice. And then you can practice this graph, whether it's on your calculator or just using the knowledge that you have. This is a negative slope, this is a positive slope, this is a greater than sign, this is a less than or equal to sign. So you can narrow down which graph that belongs to. That should be nice and simple for you. Okay, let's go back to the classwork now. Take a look at this part right here. So these high school math club kids are doing a scavenger hunt, and the items are hidden in the park. So they use these rules to help them find the location of it. So y is greater than 14. We're going to mark on our graph like 15 would be here. So 14 would be, right, these are going by 5s, just under the 15 line. And it is dotted because it is greater than. And then obviously if y is greater than 14, then this is going to be shaded in above the line because 0 would not be greater than 14. So it's an easy one to test. And then x is less than 10. So now we're looking at x. And again, dotted lines still. And it's less than 10. So in this case, if we were to test 0, 0 is less than 10. So that will be shaded on this side. And so our overlapping area is where that pink and that yellow are overlapping, kind of creating an orangey color. All right, our next one is x plus y is less than 20. Let's rewrite this as x is negative x plus 20. So we have our slope-intercept form. We're starting at 20, and it is a slope of negative 1 over 1. So I can also do that as down 10 over 10, down 10 over 10, because 10 over 10 equals 1. It's less than, so we're going to do our dotted line. And 0 plus 0 is less than 20, so we know we're going to shade on the below that line. Okay. Then it says x is greater than 6. So now we're looking at any place that x is greater than 6. So 5 is here. So our line for x is greater than 6, x equals 6 would be approximately here, creating a vertical line. And it says greater than, so anywhere that 10 is greater than 6, for example, so that side of the line is going to be what we shade. And so now the part that we're looking at that overlaps is in this little triangle here. All right, so let's look at clue number 3. So now we have, let's start with the first one, y-intercept of 20, slope of negative 2 over 1, negative 2 over 1. Now again, we're looking at these mostly in 10, so let's make this as negative 20 over 10. Okay, it'll be easier So we're going to go down 20 over 10. This gives me another point that I can use, right? And so I can go ahead and connect these. We're doing dotted line here. And it's less than, 0 is less than 0 plus 20, so we know that we're going to shade this side. Then our other equation is starting at a y-intercept of 10, same slope though, so going down to over 1. We could also make this, let's say we multiply that by 5, so we have negative 10 over 5. That might be easier to count here. So down 10 over 5. It's going to be looking something like that there. And so this will also be a dotted line, and it's less than. So we're looking at this part right here. Okay, so that's where that overlaps, is that very tiny triangle there. Now notice that these have the same slope but a different y-intercept, so that does tell us that the lines are parallel. They aren't going to intersect. However, we can still find an inequality for this because the shaded area, they do have a shaded area that is in common. All right, so let's try this one. I'm going to just switch this to y is less than x so that we have it in slope-intercept form. We can start at the 10. We're going down 1 over 1, so down 10 over 10. Oh, actually, no, my bad. Let me erase that. This is a positive slope, so we're going to go up 10 over 10, up 10 over 10. And this time we have a solid line because it is greater than or equal to. And greater than or equal to means that 0 is greater than 0 plus 10 is not true, so this point does not work, which means we're going to shade on the other side of the line. And then we have x is greater than y, or y is less than x in this case, and so that would be starting at an origin and going up 1 over 1, right? So we're going to have nice even increments here. And so again, we have same slope with a different y-intercept. This is going to be dotted. And now it says x is greater than y, or y is less than x. All right, so if y is less than x, if we were to try, let's say we do 20, 0, for example. So that would be 0 is less than 20, or 20 is greater than 0. That does work. Versus if I were to use this point, or let's say I use this point here, 10 comma 15, 10 is greater than 15, right? No, that's not true. So this side does not, let's see, this side here does not work. What this side does work. So that means we're going to highlight this side, and here there's no overlapping space, so there is not going to be any solution. Okay? All right, so that's it for this. Your code word for today is chili sauce. Chili sauce is your code word for today. Happy homeworking, and I'll see you tomorrow.